As the chair of the physics department, and on behalf of Department of Physics and the School of Arts and Sciences, I welcome you all. We are very excited to have Nobel Laureate John Hall with us today, and we will follow this program. At this time, I will request our university president, Dr. Beverly Edmond, to bring her greetings to you. Dr. Edmond.
Good afternoon. Thank you. On behalf of the entire Alabama A&M University family, I welcome you to this memorial lecture series. I've had the opportunity to chat with Dr. Hall and his wife, his lovely wife, and I'm so excited, even though I don't know the subject matter. This is always when I come to these physics lectures that we as social scientists realize where we are in the pecking order. But I so much appreciate the fact that the Department of Physics has continued this important event. I'm so appreciative that we have been able to invite not only our students, but people from our community to come to Alabama A&M University and to participate in this intellectual endeavor. You know, this is really what the university is all about. It's the opportunity to take knowledge and to make it practical in the sense that we bring people together to talk about issues and research and other important things within disciplines that are very, very important to our society. So I am so excited to have you here. I look forward to the lecture series. I look forward to your engaging questions, and I look forward to hearing from Dr. Hall. Thank you very much.
Thank you, Dr. Edmond. The next I will request Dr. Maureen Stewart, who is our Provost and Vice President for Academic Affairs, to come and give you the purpose and occasion for today's lecture. Thank you.
Good afternoon. And I need to tell the President that even when you're a scientist, as I am, a biochemist by training, the physics is still confusing. Welcome to the 11th Annual Pusha Venkateswarlu Memorial Lecture at Alabama A&M University. This year we have the Nobel Laureate John Hall delivering this lecture. We are holding this lecture series to honor the contributions of late Professor Venkateswarlu to the physics department at Alabama A&M University. This is the 11th annual lecture in that series. In the last 10 years, 10 other Nobel laureates have given this annual lecture. Professor Venkateswarlu obtained his PhD in physics from Benares Hindu University under the guidance of Professor Asunde, a leading spectroscopist of his time. He went on to perform postdoctoral research in various reputable institutions around the world. He worked with 3 Nobel laureates, Professor Niels Bohr in Copenhagen, Professor Gerhard Herzberg at NRC Ottawa, and Professor R.S. Mulligan at the University of Chicago. In India, he worked at Aligarh Muslim University and the Indian Institute of Technology in Kanpur. At IIT, he also held the position of director of the institute. In both institutions, he was responsible for setting up world-class research laboratories. He supervised the dissertation work of over 50 PhD students and several master's students. He published over 200 research papers in refereed journals. He joined Alabama A&M University in 1982 as a professor of physics. He initiated the experimental research in optics at the university, and the physics department flourished during his tenure. He attracted about $4 million in research funding. He was instrumental in setting up world-class facilities for optics and laser research, and he supervised the thesis of the very first PhD student at Alabama A&M University. He was also the co-advisor of the very first black female physics PhD recipient in the state of Alabama. During his tenure at Alabama A&M, About 10 students obtained their PhDs and 11 completed their master's degrees. Professor Venkateswarlu passed away on August 8, 1997, after a sudden illness at the age of 76. Even the night of his death, he worked in the department until the end of the day. In recognition of his service to the university and in his memory, Alabama A&M University administration approved an annual memorial lecture series. Now Dr. Reddy, Professor of Physics, will introduce the Nobel Laureate who will deliver the lecture.
Good afternoon, ladies and gentlemen. Today we have the distinct pleasure of listening to a distinguished scientist, Nobel Laureate, Dr. John Hall, and it's my privilege to introduce you. Dr. Hall was born in Denver, Colorado, and obtained his bachelor's, master's, and PhD from Carnegie Institute of Technology. So immediately he joined at the National Institute of Standards and Technology, formerly known as National Bureau of Standards, as a postdoctoral fellow. After a year, he became staff physicist and later on senior scientist, and he worked there for more than 40 years. He was a founding fellow of JILA. From 1967 onwards, he held a joint appointment in the Faculty of Physics at the University of Colorado Boulder. So Dr. Hall has been the thesis advisor of many doctoral students at the University of Colorado Boulder and has published more than 235 papers in top-rated scientific journals and also had about 10 patents on his name. He is a very renowned spectroscopist and a preeminent experimentalist. He is known for making extreme precision measurements. His work has made it possible to measure the frequencies with an accuracy of 15 digits. His work on the development of the methane stabilized helium neon laser led to the speed of light measurements with 100 times better accuracy than any previous determination. So this work ultimately led to a redefinition of the fundamental unit, meter. He is recognized as the person who defined the speed of light and as the world guru of laser stabilization. His work has applications for the development of extreme accurate clocks, improved global positioning system, laser interferometer, gravitational wave observatory, accelerator projects, and for the detection of exoplanets. He received numerous awards that include 3 gold medals from the Department of Commerce, 1 individually and 2 with a group. So this is the highest honor given by the Commerce Department for personal and professional excellence. He also received the Presidential Rank Award from the Office of Personnel Management. The recipients are selected by the President for their exceptional leadership, accomplishments, and service for an extended period of time. He also received several prestigious awards from professional societies that include Charles Towns Award, Arthur Shallow Award, Max Born Award, Frederick Ives Medal, Robbie Prize, and many others. So Dr. Hall received honorary doctorate from the University of Paris and University of Glasgow. He received the Physics Nobel Prize in 2005 for his contributions to the development of laser-based precision spectroscopy, including the optical frequency comb technique. In addition to his numerous achievements, Dr. Hall and his wife Lindy are also very involved in philanthropic activities in their community. They founded SciTex, an organization which aims to prevent the declining interest in math and science in elementary education by using hands-on exploration and interactive workshops to demonstrate scientific principles. So Dr. Hall is married to his wife Lindy for 52 years. So without further ado, it's my great honor to invite Nobel Laureate Dr. John Hall. Thank you.
Thank you. One right here.
I think the word I appreciate in the audience, we have Mrs. Hall sitting here, so we welcome her. Please stand for a minute.
Okay, well, I keep looking around to see where such a person is, because I'm just me. I've been really lucky to have good experiences, and I'd like to thank every one of you, and especially your parents, for the taxes that have sponsored this laboratories, the research over all these years. So this is a celebration, a victory lap for us all, but how ideas from science and technology keep pushing ahead, and a few late nights each month maybe about getting a great signal, and I'd like to stay later tonight and see how it turns out. And little by little by little, if you're super lucky, it's really my main principal recommendation for you is to try to organize things so that the good luck will fall on your side. And then something actually good can come out of this 45 years or something that you've put in. I didn't realize that the Venkateswarlu, who was in your university, was the guy who I knew that was doing nonlinear optics. So I had met him in a conference, and I'm really pleased to have this closure. I have pointer, thanks. So the activities that I'm going to talk about have happened in a village that's located by these mountains. We're also limited by mountains, and luckily the city doesn't allow water to be served, public water, on higher up these mountains, and so we grow away from the mountains, whereas you seem to grow in a line because there's another thing like an army base that blocks. So the topic for today is I'd like to tell you in what I hope it will be an understandable way about something called an optical frequency comb. And I think all of you know what a Swiss Army knife is. And if you think what your life as a camper or host on a beach party with trying to open a wine bottle, or to tighten a screw in your car that's rattling, and you didn't have a Swiss Army knife, this would be a serious problem, and you would really be aware that you didn't have it. And what's happened in 5 years ago or something is that a new kind of Swiss Army knife came into existence, and it's just as versatile, just as powerful, and I'd like to help you see a little bit about what's fun about it. What I've just illustrated is that nobody lasts forever, and if you're incredibly lucky, you'll have a student or two who is, you're not only glad to have them come through, you're even glad to see your lab get given over to them. So that's the case with Dr. Jun Yi. The funding for this, as I mentioned, is coming from your taxes. It's worked out pretty well. Another aspect of this is that there's been a growth experiment. This was the first experiment that we did in this country about whether state university could collaborate with federal laboratories and have a success, have the sum turn out okay without one of the parents grabbing it and making it do program stuff. And I've got a picture here that shows the development of our building. Let's see here, why is that? There we go. This building in a construction phase, it shows also 3 citizens that share DNA with my wife and myself, and now in the later time have produced grandchildren for us. So the issue of what do you want to do with your life is an important thing. And here's a guy, Peter Terran. He was one of the ace students in Perth Department of Physics in the very west-hand edge of Australia. Good student, except that he didn't always come. And he was fooling with stuff at home, which, for example, is really high voltage electricity. This is 7 million volts, and it makes some certain amount of sparks. Now, if your parents were sort of the same style as mine, they would say, good heavens, now what are you fooling around with that kind of stuff for? Why don't you get a job and do some, I think you know how that